Hello and welcome to this video where I will be showing you how I created this structure inside Grasshopper, doing it parametrically. This structure is inspired from a book which is called Structure Systems, written by Heino Engel. That's the author. I will leave you a picture right here, and I will also write down on the description some more details about this about this book. And the goal of this video is kind of just guide you through my process. I will be showing you all the script. I won't be doing it from scratch. I will just be showing you the total result, and I will be guiding you how I did the different parts of this structure. To start with, I would like to show you what parameters you can control. First, it's the number slider of the segments. So you can do a polygon of several segments according to your needs. I will start with 3 because that's actually the structure that I found on the book, which is, before I forget, it's a structure system and it's an example of a typical structure form. And this one specifically, it's a post beam casing with single bay bracing and diagonal floor girders. So this is what the structure looks like in the book, more or less. And that's why I kind of added my idea of trying to do more segments instead of just 3. So this is the first number slider. The second one is the radius, so you can increase or decrease the radius. You can also increase or decrease the chamfer edges. I will move a little bit just for you to see. Then also the thickness, I will zoom in so that you can see what I mean with the thickness. So since each of these elements are B-rep, then you can increase or decrease the thickness of this material. The width as well, so I will go more on a top view, so you can kind of make the material a bit more thin or on the other direction. Then the corners offset, I kind of did these profiles. That's how I interpreted it from the book. Kind of to do these corner profiles, and this is the offset where you can control them. Also, you can control the step between the floors, so kind of like the distance between each floors. You can also control the number of floors if you want a higher or a not so tall structure. And also here on the corners you have this kind of X's that in the book they refer to them as diagonal floor girders. And this is where you can control the diameter of these ones. So you can increase or decrease this X diameter. And then also, just to finish, the width of the corners, what I mean with this is kind of just, you can control this distance of the corners. If you want some profiles which are a bit larger, then you can just modify this to your preference. Okay, so that's what you can do with this parametric structure design. So what I will do, I will kind of hide the final result and I will start from scratch. So first of all, I started with a polygon, with a triangular polygon, as you can see over here. I think I will also just quick inside my Rhino, I will hide my grid and planes so you can see, I think you can see this easier. So first I started with a polygon of 3 corners. As I said, you can increase or decrease, but I started simple with 3. Then what I did was exploding it, and from this explosion I extracted the curved middle of each of the segments. So you can see right here. And the reason why I did that was that later I used polyline to create kind of the inner part of the structure. So that was just kind of a simple start of the script. Then the next step was doing the chamfer. So I used this component of curve shader, where I divided these first curves, the ones you are looking right now that are color green. These ones I separated on these middle points. So right now we have per side 2 curves. And I selected both of them with a list item. One of them curves I used flip curve. Then I used merge to connect them so that I can do on these curves an evaluate curve, which will help me with the chamfer. So if I connected all of these curves, then I have the polyline, which is like this. And the reason why I flipped the curve was kind of to be able to use the right direction for the position of the points. So this was the beginning. I will hide the very first parts because that will be a bit too much when we continue. Okay, so now we have this. The next step was kind of doing an offset to generate the surfaces. So what I did was first the inside part, I did an offset to both sides. I know that there is a component which is offset curve, and then you can offset it on both sides. For some reason on my Grasshopper it wasn't working, so I needed to use this kind of equation where you would just connect the same distance, but you use a negative component and you connect both numbers inside the distance, and that's how you get the offset curve on both sides. So that was the first part. Now I will hide the first curve. And the outside curve, I did an offset of the same distance but multiplied by 2, and that was my approach to kind of use the same distance as the first triangle, but kind of to be able to connect them like this so that we don't have any extra or residual corners that we don't like. So that's why I multiplied it by 2, and then I have the same distance but just in another approach. When I do this, then I created the boundary surfaces on each of them, and then with this process on top, the reason why I used solid union and merge faces is because if you see right here, both surfaces are kind of overlapping, and when or my vision for this script was to have everything as simple as possible, so I decided to join both of them with a solid union. I will turn it on in a moment. And now that they are both joined, I will turn this off. As you can see, everything is off. I only have the solid union component on. But here you still see this line, which is where both surfaces are connecting. And that's why you can use this merge faces component. So if you turn off the solid union, then you don't have these faces any longer, and you have one solid surface or one continuous surface. Now for this, or for the next step, I just use offset B-rep, and this is connected to the slider at the beginning, so where you can control the height of this or the offset of this surface. So that was the first step of the script. Following, I will continue down here, and I will turn off the offset, and I will continue with this outer curve. Because the next step was to do the corners of this. I don't know if you can really see them, but these are the profiles that go all the way up of the structure to give more supports on the corners. And how I did this was I have the offsetted curve of the result from the previous steps, and then I just applied an explode. Then I used here the segments of each of these, like to have these curves individually. And now I used here, as you can see, an evaluate length. And the reason why I used this component is because when I was trying to place the points here with evaluate curve, for example, you see that the curves or the lines have different lengths. Like we have 3 with the same length, and then we have other 3 with another length. So if you are trying to do this type of process where you want the points to be on the same, like on the curves, on the same distance, but trying to keep or without taking into consideration the length of the curves, then you can use the evaluate length instead of what I was doing, and that was a mistake. What I was trying to do reparametrize curve. So when you reparametrize the curve length gets kind of transformed from its original length to the domain of 0 to 1. So if you are trying to do this, then that means that if here in this curve you place a point in the middle, so 0.5, then the point would be here, but on this curve the point would be here. So it's not the same distance. And what I wanted to do is give them the same distance, and that's why I used evaluate length with normalized in false. And that's how I achieved these points on the corners. And after that, then I just needed to do a little bit of data management for the polyline to be created like this between the curves, or the points, sorry. And yeah, that was basically it. I will turn this off. And this was the final result, where then I just extruded according to the height of our structure that you can see right here, that I used some mathematical components like subtraction and addition just to get to the same height of our structure, depending on the material thickness. So that was the part of the corners. And now coming to this middle part of the script, this is where I will explain let me just turn this on real quick. This is where I explain the x's. I don't know how you guys call it, but this is how I started. I will just delete this. Okay, so what I did first for this step was to have the exploded segments of this base curve as well. And then I used a dispatch component so that I can only get, I will connect here just a curve component for you to see, so that I could only extract the like the smaller part of our polygon. So this would be the chamfer edges actually. And these curves, I also arrayed them on the same direction, like on the Z direction. And then after this, I used also a dispatch so that I could have kind of one curve yes and one curve no, one curve yes, one curve no. And then after this, this I can also delete. And then after this, I created, or I used the component endpoints to get the endpoints of each of these curves. And then I used these equations, or I used these components to generate the x's. So basically, I needed to shift the list of both of the points, and then I used here the last index component, which is from I think it's, let me check the plugin, it's Pufferfish plugin. So this is a really handy component Of course, you can also select the last index by using the default components inside Grasshopper, but this is normally how I do it. And after that, I just connected the lines in this way. And when I had the X's then, or the X's, then I just connect them to pipe. And this was the third part of the script. So basically, I think it's not complicated. I used very normal, like workflow, a very normal workflow, a simple workflow. And at the end, you have three different parts. So first is the kind of the structural frame, then you have the X's, and then you have the corner structures. So that's it. And I will also leave the link where you can get this definition if you would like to try it out and change the parameters. I am selling them for a very affordable price, an attractive price on my website. So I will leave you the description. I will leave you the details in the description below so that you can just get it and play around with it. And I hope you can build and create very interesting structures. Make sure to subscribe, to follow me on Instagram. I will also leave here like my Instagram, where you can find also some of other structures that I've done so far. And see you on the next video. Thank you very much.